Order, order! Silence in the court. Hello, ladies and gentlemen. Welcome to the court of law. We have an interesting case like this, which I never saw. Mr. Feinstein is the prosecutor. Mr. Holland is the defense. The case is regarding graphene. Let's see how it makes sense. The convict is graphene. They say it shows superconductivity. Mr. Prosecutor, would you care to explain and please proceed?
My lord, there are more things in heaven and earth than dreamt of in philosophy. We have here Mr. Graphene as the convict, and let me tell you the story of his rift. I'm sure you all know what is graphite. It is in your pencil when you write. If graphite is like this deck of cards, then graphene is just one of them. Yes, it is thin and strong, which makes it quite of a gem. Graphene is carbon atoms arranged in a lattice, which looks like a honeycomb with atoms at ease. Surprising more than ET is graphene showing superconductivity.
Well, that is not a convincing word. I have an objection, my lord. Objection sustained. Would you care to explain, mister?
Yes, of course. I would like to invite my first witness, Mr. Electron. Mr. Electron, would you take your stand in the witness box?
You have my permission. But why is the electron so hazy?
Your Honor, that's the law of Mr. Heisenberg. If you can see an electron, you can't tell how fast it's moving. That's quantum uncertainty, and that's what I'm loving. Mr. Electron, please let the court know what is superconductivity.
Your Honor, it's a privilege to be a witness, and I must say this is a very interesting case. Now listen to me. When I flow from one end to the other due to a potential, people call me a current, the ones who are rational. When I flow in a metal having some ions, it blocks me like Hercules fighting lions. This hinders me, blocks me, stops the essence. This is what physicists call resistance. However, when in some materials I flow, resistance is zero, which gives the mind a blow. Superconductors are what they are called, where resistance comes to a halt.
Exactly, and such an event occurs when you have bilayer graphene twisting one and not the other. Superconductivity is happening. Mr. Defense Counsel, your witness please.
So Mr. Electron, you are very steamy, like John Cena's You Can't See Me. Would you care to explain as we meet, how do you show superconductivity in graphene sheet? Mr. Defense Counsel, the reasons are composed of many complex things, which is not fully understood, like Pegasus wings. I have energy and momentum when I flow like a current. Band structure, it is called when you plot both of them. The bands you get can have a gap or not, which will tell you whether a material is a metal or not. But for bilayer graphene, it's a different one. It looks like a cross, like photograph 51. When you twist the layers, the bands get flattened. And that's when scientists say that we are superconducted. The twisting angles are magical, and that's why research is so critical. If you ask me why, alas, I have to blame it on your fate. For scientists have not found a single reason till date. They call this superconductivity unconventional, which can be studied using density functional, which is a theory in quantum mechanics to solve equations of condensed matter physics. Experiments confirm this too, which Mr. Counsel is clinching evidence to be true.
So you can see, Your Honor, that the point has been proven and is quite novel. The defense has been outwitted, giving just a glance. With that, I rest my case, but not my stance.
Hearing both sides and the power vested in me, I announce Graphene guilty as charged. However, this guilt might be a boon in disguise because we need superconductivity in science. But till that day, this case comes to a close. The court is adjourned.